Good morning, students. Today we will discuss one IoT experiment, that is controlling of LED lights from a web server using ESP8266 Wi-Fi module. The components required for performing this experiment is NodeMCU, Arduino IDE, breadboard and connecting wires. NodeMCU is an open source IoT platform. It includes firmware which runs on the ESP8266 with system on chip from Express Eve and hardware which is based on ESP12 module. The term Node MCU refers to a firmware rather than the dev kit. The firmware ESP8266 uses the Lua scripting language. It is based on Lua project and built on the Express non-OS SDK for ESP8266. It uses many open source projects such as Lua, CJSON and SPIFS. ESP8266 Wi-Fi system on chip as well as an open source hardware board that, contrary to the ESP8266 Wi-Fi module, includes CP2102 TTL to USB chip for programming and debugging. In this diagram, you can observe that this is ESP I2E chip. On this board, there is 3.3 volt voltage regulator, 2.4 GHz antenna is available for this Wi-Fi module. There is a flash button and reset button which is used while uploading the code, and micro USB port is available. Here there is onboard LED pin which is connected to D0, a pin of this input output. In this diagram, you can observe the pin configuration of Node MCU. This is ADC 0 pin for the internal ADC which is available on board. These two pins are reserved. General purpose IO pins are available. This is GPIO 10, GPIO 9 pin. Then these pins MOSI, CS, MISO, serial clock. This all are used in serial communication like I2C and SPI. 3.3 volt power supply is available on board. 3 power supplies you can see. This is the voltage input pin, ground pin, and this side also GPIOs are available. This is the pin configuration of Node MCU. Now the GPIO pins which we have seen in this diagram, these pins cannot be directly used in programming for addressing the IO pins. You cannot address a particular pin as GPIO 0 or GPIO 1. Instead of that, the index number is given to each GPIO pin and we have to refer this particular GPIO by using the IO index number. If you want to refer GPIO 13, that is general purpose input output pin 13, then you will have to refer it as 7D7 pin. That is the IO indexing number which is given to GPIO 13 pin. So for each and every GPIO, particular IO indexing number is given. This is the interfacing diagram of our experiment. Interfacing diagram is very simple. In this you can observe that the node MCU IO pin is connected to the LED which we want to control by using ESP8266 Wi-Fi module through this resistor. The negative terminal of the LED is grounded and positive terminal of the LED is connected to the GPIO pin of node MCU through this resistor. Here you can observe the same connection where D2 pin, this is the node. Instead of D2 we can use any other GPIO pin. It is not necessary that every time we should use uh, D2 pin. We can use some other GPIO pins. So here this D2 pin is connected to this LED by using this resistor. Negative terminal of the LED is connected to ground. And this is the micro USB cable which we will connect to our laptop or PC through the USB connector. Now we will see how to program this node MCU. Now you can observe in this window our Arduino IDE is open. The version of Arduino IDE which we are using is 1.8.13. Now before writing the program, in this program, now we can observe that ESP8266 Wi-Fi, this library is used. So if this library is not installed, then the first thing we have to do is to install the ESP8266 Wi-Fi library. That we can do by using this tools menu. Go to manage libraries, and if you click here ESP8266 Wi-Fi, then it will show all the libraries. Now in this case all the libraries are installed, so that install option is disabled. Okay, so if a particular library is not installed, then the first thing we need to do is to install the library. Okay, now this is a Wi-Fi experiment. We have to connect our node MCU to the Wi-Fi. So we will use the SSID user ID and password of the Wi-Fi which Wi-Fi connection which we will be using in our program. Okay, now GPIO pin number 13 we are going to use. GPIO pin number 13 and that we will define as integer LED pin. So throughout our program we will refer GPIO 13 as LED pin. Okay, Wi-Fi server address we need to give, that is 80, and we know that Arduino our Arduino program is always there in only two functions, that is void setup and void loop. Okay, so in this void setup function we will do all the initialization. For initially we will use the for serial communication, because we are going to use the serial monitor window. Serial communication baud rate we will select as 11 5200. Then pin mode we will define LED pin, that is GPIO 13 pin as a output pin, and initially we are writing 0, logic 0 on the GPIO pin 13. Okay, then we have to on serial monitor window we have to print this message connecting to, then it will also display the as a connecting to the name of the SSID, and it will begin the Wi-Fi connection with the Wi-Fi, which user ID and password which we have given in this program. Okay, then as it will check whether the Wi-Fi is connected or not. If the Wi-Fi is connected, then it will display the message Wi-Fi connected and server started, because our node MCU will be acting as a server. We are making that device as a server, and that server will be we are connecting the LED pin to that node LED uh, to that node MCU, and then that node MCU will act as a server, and through that server we can control the turn on and off of LED by using the web server. So it will display the message server started, and then uh, it will display the URL of our local server, which is nothing but the node MCU. Okay, so our node MCU will act as a server, so we need to have to get it connected to that server, we need to have its URL, so that URL will be displayed by you on this serial monitor window once we execute this code. Now next is all the initializations we did in void setup function, and now further program is written in the void loop. Initially we will check whether the server is available or not. So Wi-Fi client is equal to server dot available. This function will check whether server is available or not. Okay, and client will be the HTTP client will be the HTTP web page, and server will be our node MCU. It will again display the message new client. Okay, every time we execute the code, and whenever particular uh, client opens that web page, it will display a message that it is a new client and client is available. We know that HTTP runs on the request response model. So we have studied the different communication models mm, in computer network. And if we are using the HTTP page, then HTTP works on the client server model, and our node MCU is a client device, and the device where you will open the web page for controlling of the LED will be the client device. Okay, so now next is for next code is for uh, controlling of the LED. Okay, so if the request is received for LED off, it will turn off the LED, and if the request is received for LED on, then it will turn on the LED. So server, our node MCU server will take a decision depending on the request received from the client. Okay, and this part of program is for the designing of the HTML page Okay, so in this part of the code, our web page is designed with the two buttons on it, that is turn on the LED and turn off the LED. Okay, so this is about the code student.
Good morning, students. Today we will perform one IoT experiment, that is controlling of LED lights from a web server using ESP8266 Wi-Fi module. The ESP8266, it is a microcontroller which is designed by Express If Systems. It is self-contained Wi-Fi networking solution offering as a bridge from existing microcontroller to Wi-Fi, and it is also capable of running self-contained applications. As you can see in this diagram, this is a node MCU. Various GPIOs are shown in the node MCU. Here, in this diagram, you can observe that these are the different pins of node MCU. This is ADC 0. These two pins are reserved. This is general purpose IO pin 10. This is general purpose IO pin 9. This pins MOSI, CS, MISO, serial clock. These pins are used in I2C communication. This is the ground pin. 3.3 volt power supply is available here. This is enable, reset, ground and voltage input. If we see this side, then this side also 3.3 volt power supply is available. GPIO 1, general purpose IO 3, which are combined with transmission and reception of serial communication. This is GPIO 15, GPIO 13, GPIO 12, GPIO 14. This is 3.3 volt power supply. This side it is GPIO 16, GPIO 5, GPIO 4, GPIO 0 and GPIO 2. So, if we see this D7, here D7 is written. So, this D7 is nothing but GPIO 13. So, we can use this as general purpose IO pin. You can see on this module Wi-Fi ESP8266 is inbuilt. We can use this module in self-contained applications. We have seen how to download the code in NodeMCU board. Now this board is connected. This is NodeMCU board, which pin configuration we have already seen earlier. Now this NodeMCU is connected with the laptop by using this USB connector. What we have to do, we will connect pin number 13, that is D7 pin. Now you can observe here that this is D7 pin where I have connected this connector. This D7 pin is connected to one terminal of this resistor. This is resistor of 1 kilo ohm. Then second terminal of this resistor is connected to the positive terminal of this LED. Negative terminal of the LED is connected to the ground, which is nothing but the ground pin available on board itself. We have earlier seen that there are 3 ground pins and 3.3 volt supply pins available on this NodeMCU itself. Okay, so we are using that ground connection to ground the LED terminal. By using the Wi-Fi module which is available on this NodeMCU, we will control this LED remotely by using the web page. Okay, so how it is done, that we will see now. Initially, we will compile the code by using the compile tab available in Arduino IDE. You can observe here that it is showing the compilation process. Now the compiling is done. Once the compiling is done, now we have to upload the code inside this NodeMCU memory. Okay, so we will now press this upload button. Once we press the upload button, after pressing the upload button, we have to press these 2 switches simultaneously, reset and flash switch. Without pressing this reset and flash switch, we cannot upload the code on this NodeMCU. So now it is showing that uploading is finished. Once the code is uploaded, now it is ready to execute. We can open the serial monitor window. Now in this serial monitor window, it should show the URL. Now we have opened the serial monitor window. You can observe this URL here. It is 192.168.105. This is the IP address of the server, NodeMCU server, web server. Now this NodeMCU has become a web server, and this 192.168.0.105, this is the IP address of this local server. Now we have to take care that our Wi-Fi network should be connected while we execute this code with the same SSID and the password which you have mentioned in this code. Student, you can see that we are using the same URL which we got in serial monitor window. It's 192.168.0.105. Now we can use this URL to open a web page which is designed to control the LED. There are two tabs in this web page. One tab is for turning on the LED and other tab is for turning off the LED. Now by using this URL web page, if we turn on the LED, now you can observe that this LED is turned on. It cannot be turned off until we turn it off from this tab. Now you can observe the LED is turned off. This is how we can control the LED by using the web page which is designed to control the LED. Instead of this LED, we can use any other device like fan, refrigerator, air conditioner. So this NodeMCU can be used in home automation system to control the home appliances remotely. Okay, so this is how we can demonstrate that how to use the ESP8266 module to connect the NodeMCU with the Wi-Fi. Thank you.